Okay, Brittany, you going to do the clicker? Wow. Hi, Mom. Good evening, everyone. My name is Rory Moore, and I lead the ComNexus organization. Let me first begin by thanking tonight's speakers. You're going to see them tonight. I'm confident that you'll find what they say not only educational, but really inspiring. These individuals operate at ground zero in robotics, and you're going to learn some things tonight you've never heard of before. I also want to welcome the press. We've got the Union Tribune here tonight, Exconomy, the San Diego Business Journal, and the Daily Transcript. All the papers are covering this event tonight, so we know we're doing something right. Thanks for coming. Tonight's turnout, I think, set a record for ComNexus. The last time we had a record turnout was when Marco Thompson substituted for me at the Q Auditorium in December while I was off scuba diving for a week. And that was standing room only. So tonight even broke that record, Marco. Sorry about that. Okay, I also want to especially thank the exhibitors that were out there today. I think you saw a lot of things that you want on your Christmas list. So get online, order it up. Thanks for 3D Robotics, 5D Robotics, UCSD Robotics Lab, Qualcomm, Verizon Wireless, SD Genie, Aerial Mob, and Clever Pet. Thanks for coming tonight. Okay, next slide. Thanks, Qualcomm. Everyone enjoy the food? Terrific. Qualcomm's our sponsor tonight. That's for a couple of reasons. Number one, their CTO is fanatical about robotics. That's Matt Grob. In fact, I have reliable information that Matt in the Trans-Pacific flights on the Gulf Stream actually flies his little drone inside the Gulf Stream. I think that's true. And did you know that Dr. Paul Jacobs got his PhD in robotic systems? There you have it. So lots of history at Qualcomm with robotics, and you'll see that they consider this a very serious space. Next slide. Here's our sponsors. These folks help us do what we do best. Most of what we do is pro bono for the community, and we use their sponsorship dollars to do that. When Martha Dennis and Marco Thompson ran the organization, I think they had 3 sponsors. No, actually they had more than that, but we've improved upon that. Thank you very much for those sponsorship support. I'd like to announce something special tonight. How many of you here work at Qualcomm? Raise your hand. Then you know who the heck this company is, ARM. Right? All right. So ARM isn't even based here. They're in the UK. Do you know what ARM stands for? Who knows what that stands for? What is it? God. Advanced Risk Machine. All right. I'm dating myself. Anyway, a round of applause. ARM has joined ComNexus as the major sponsor. Okay. Last headliner event we had with Digital Health, we announced a new partnership at EvoNexus, our incubator, and that was Cisco Systems. We have a third, Mitchell International. Mitchell International is the world leader in insurance, software solutions, and analytics for property and casualty. So if you've ever had an auto accident, and I know you have, and your kids have, that estimate was performed by Mitchell. So they're locally based in San Diego, and they're a new partner at EvoNexus, and they're, along with Qualcomm and Cisco, providing startup capital to selected companies in our incubator. Speaking of our incubator, there are the results. Check it out. $573 million in funding and outcome, 7 acquisitions. Qualcomm purchased one of our companies last year, over 1,000 jobs created. So, as Marco Thompson told me one time, there's nothing more important in San Diego than this incubator as far as starting new companies, and he's proven to be true. Okay, rather than me tell you about what's happening at EvoNexus, and there's a lot happening, let me take you to EvoNexus. We began the incubator to grow new companies and jobs in San Diego, high-value jobs in technology, and create wealth.
EvoNexus is a no-strings-attached startup incubator.
EvoNexus is a community. EvoNexus is a hub for startups to come together and grow. Being part of EvoNexus means that you will be among the best and brightest of San Diego.
We'd had a vision of what an EvoNexus should be for a long, long time. And then one day we said, this is the right time.
It's a place where entrepreneurs know that they can go to get good information, to find the right mentors, to meet cool companies, to get internships. It really has become a hub for San Diego entrepreneurship.
Well, I think in San Diego, Evo has become sort of synonymous with the startup community. Having been here for many years, there really never has been a ground central, a sort of ground zero for startups. And I think Evo over the last 2 years has really become that.
If you're a startup that really is looking for mentorship and collaboration with other like-minded and like companies, this is the best place to be.
What EvoNexus provides is support for entrepreneurs, whether that be HR support, legal support, not directly but through the mentors and advisors that are associated with EvoNexus.
To have introductions to strategic investors, strategic people that can be on the advisory board, etc.
EvoNexus is like an energy drink for your startup.
The opportunity to better succeed at a very risky proposition.
Ground zero for entrepreneurship and startups in San Diego.
EvoNexus is a startup itself. So we've already evolved over the last few years. I think we'll continue to evolve to really serve the needs of the entrepreneurs.
It's a great way to learn about startups. It's a great way for startups to learn about how things are financed and how to get themselves set up.
It is the purest form of pay it forward that a community, San Diego community can do.
EvoNexus is the fastest way to launch your startup. How about that? I want to pay special recognition to a one-man band that did that video, Rafa. There he is. Okay, next slide we have, those are our two locations, downtown San Diego and UTC, and a third location that we're opening in November in Irvine, right next to UCI, within walking distance of the Samueli School of Engineering. EvoNexus Irvine is officially launched. We have open applications, around 15 for San Diego and around 1 for Irvine. We're already getting apps in, so spread the word. As you know, it's a totally pro bono incubator. There's no better place to start your company. Next slide. Okay, little company called Samsung coming to town. Looking for interesting new companies. Their areas of interest are posted on our website. It's long, unbelievably long, so there's probably not a lot of things out there they're not looking for. All you have to do is apply. It's a free program. Samsung will vet you, select who they want to meet with, and then when they're in town, you'll get a 1-hour meeting. Now, they're not going to choose everybody. They may look at 200 apps and they may choose a dozen companies, but those dozen companies have been selected by Samsung and senior executives, and your chances of succeeding with them are very, very high in these meetings. Verizon Wireless follows Samsung. Again, Fortune 500 companies, global 500 companies coming to San Diego to meet emerging companies from around the country. Okay, next slide. Let's see how smart the audience is. We have a quick question here for everybody. The first person to raise their hand and answer the question correctly wins a free ticket to our upcoming keynote address featuring 3D Robotics CEO Chris Anderson. Chris Anderson's a former editor of Wired Magazine, an amazing speaker. So if you answered this question correctly, you get a free ticket. Here's the question. What, and the people that were here the other day in the dry run don't count, so keep, or my staff. What is the most expensive robotics project ever undertaken? Quick, hurry, you. Winner. There it is. There it is. Unbelievably expensive, and it works. And a San Diego company, check it out, has chips on the Curiosity. That's Peregrine Semiconductor, a company I co-founded here. So when my mom asked a long time ago, what have we done lately? I said, well, Mom, you know, we produced chips for the Mars the rover. And she goes, how many? I said, I think 4. She goes, big deal. Years later, when I said we had chips in the first iPhone, she goes, that's a big deal. Oh, who knows? So congratulations, Brittany. There's your winner. All right. Next slide. Okay. Before I bring the speakers up, let's inspire everyone with a great video that, again, Rafa put together, created especially for tonight's program. Roll it. All right. Thank you. Who needs a big production budget, you know? Okay, while you're sitting there, connect with us, Facebook, Twitter, Instagram. Here's how you do it, up on the screen. So let's begin tonight's event. The speakers are going to come up one at a time. Their bios are in your handouts. They're going to introduce each other. So without further ado, I'd like to invite a very special guest tonight on our panel, the Dean of the Jacobs School of Engineering, Dr. Albert Pisano.
Hey, good evening, everybody. And Rory, thank you very, very much for the introduction. And I'm still bummed you didn't let me try for the question because, hey, if you have an unfair advantage, sometimes you want to be able to press that to your advantage. And I think the future of robotics is going to be defined by putting that motto into effect. What I'd like to do is just to talk for about 15 minutes, maybe 12. You stole some of my time, Rory. And acquaint you with not just the Jacobs School, but a number of important robotic initiatives that we're going forward with. So there's a picture of my world, and the engineering dean's office is basically center left in that picture. First off, hey, we're the little school next door, but we're not really as little as you might imagine. Yes, we're highly ranked, but you may also not know that there are 8,200 students in the Jacobs School of Engineering, and that makes us the largest school of engineering in the state of California. I spent 30 years at Berkeley before I came down here to be the dean, and I can assure you that the students here are great, and the school feels an incredible responsibility to providing education for the engineering talent in the area. Enough about the school. Let's talk about the direction that we are going to take robotics research. And we chose this direction very, very specifically so that it would have what we think is maximal impact. Now, the speakers that follow me are going to dive into this a lot more than I will because they're the robot experts and I'm the dean. And contrary to all rumors, no, you don't get a lobotomy when you become the dean, although some people still think that that really happens. So I'd like to in-brief you on the Institute for Contextual Robotics and why the tongue twister word. Well, you know, we took a look at a number of robot institutes around the country and we said, you know, we're the Young campus, we're the Maverick campus, we're the Can-Do campus, we're the Charge Ahead campus, we're the Go Out and Do It no matter what campus. But, you know, we don't take on strength by weakness. We don't go head-to-head with somebody in their home turf. The area that is not being fully addressed is the middle C of the 3 C's of robotics as expounded by Vijay Kumar at the University of Pennsylvania. And the 3 C's are communication, context, and contact. So if you put together a robot program that really understands those 3 things, how are you really going to communicate with that robot? How is that robot going to communicate with you? The last one, contact. You're going to be in contact with that robot's going to be in contact with the environment, other robots. And we focused on the middle C, context. Because if that robot does not understand its environs, it is not useful to you. You don't see the middle C prosecuted to the max at other schools. We are picking that direction. And we're not doing it just as engineers. We're doing it as engineers connected with cog, sci, and people in the social sciences. So this is a broad approach. The purpose of this slide is to let you know that, no, this isn't my own personal vision. 60 faculty, 60, have signed up to work on this. So, one way to get started with an institute like that is to invite in all the heavyweights you can talk into coming. And so, on October 10, we have what we call the Contextual Robotic Technology Forum. This is the list of speakers at our big presentation, and we make an invitation to you to attend. And I won't go through all the speakers for the sake of time, but I think you'll recognize a few names there, people who have really made a difference. So, in the remaining few minutes, let me just hop, skip, and jump through a couple of slides just to show you the kinds of things we're involved in. We see one of the special needs for robots, a special set of sensors, a new set of sensors. They have to meet price and performance targets. And we're looking broadly: air, undersea, a harsh environment, and limited space. One of the ways you're going to build parts of the robot and the sensors and even the circuits is that you're going to print it. But you're going to print it in a special way. And this is a way that not many people prosecute. We think this is the way it's going to work. And I won't go into the technical details except to say that we have a process by which you formulate nanoparticles of the material you want to print, 6 nanometers typically. You put them in a special solvent. And unlike every other way you can imagine printing, you put the contact stamper in contact with the target surface first, then you flow the ink. That's as far as I'll go into it. But the advantage you get from that is no ink, no particle ever goes anywhere it shouldn't go. And if you want to print small-scale features, You're going to corral those particles, keep them under tight control. This is how we're going to do it. Okay, where are you going to go with the technology if you actually have the sensors you need? Well, here you see in the upper right, offshore pipeline inspection. Upper left, whoops, wrong button, but I know how to fix that. Upper left, remote sensing soil for agriculture, in other words, right water content, etc. Lower left, and I'll emphasize this for a section, inline inspection of pipes while they are in service, and then other projects that look at basically looking at flow of gases. Now, you might imagine that pipe inspection is something that's rather important, and every now and then you hear about a water main break, right? Okay. The whole trick there is, where's the crack? But knowing where the crack is doesn't solve the problem. The real problem is, how do you repair the crack? So now, I'll wrap up. Well, now let's imagine a future in which you have a robot, it understands its context, it can go into a harsh environment, and it can communicate. It actually can locate a crack. And using some of the same nanotech we use to build the robot, you actually can flow repair material into the crack, direct it there with a magnetic field, initiate a reaction, and seal the crack. And indeed, first prototypes of filling and sealing that crack by using a spark to initiate the reaction are already being completed. So, I think the time now is to think extremely broadly about robots. Yes, we'll skip through these because I want to stick to the time constraints. And I'll just summarize by saying they're coming. They're not just going to fold the laundry for you. We're talking about doing major innovative repairs and other things. They're going to be talking to each other, and the Internet's going to be a major part of that. Thank you very, very much for your time and attention. We're done at 6:40. Okay, while Tim comes on up, I'd like to have the pleasure of introducing Tim McConnell, who's the Director of Engineering for 3D Robotics UAV Technology. Tim, podium's yours.
Thank you, Al. Thanks, Al. That was great. Thanks, everyone, for coming. It's nice to see you all. It's a real pleasure to be out here with you. I'd like to thank Rory and Brittany for all the hard work that they've done putting this together, as well as all the people at CommNexus and Qualcomm. Really exciting event, and it's exciting for me to be up here with three giants of the robotics industry, so I'll do my best to stand tall up here as well. My name is Tim McConnell. I'm the Director of Engineering at 3D Robotics here in San Diego. I started my career here in San Diego in 1984 working for a little company up in Torrey Pines called Linkabit. Perhaps a few of you have heard of it. How many people here have roots that go back to Linkabit? Yeah, good number. Yeah. So anyway, that was a fun job. I've had a lot of other interesting jobs in that time. And for all of them, none of my kids could really tell you what I did at those jobs. When I took this job at 3D Robotics, I got a text from my daughter at Olin College of Engineering that said, "Dad, all my friends think you're cool." It's a cool job. It's a cool company. We make really cool stuff. This is our Iris that you probably saw outside, saw some of our robots flying around. We do great stuff in the consumer space, and it's really fascinating work. But that's not really what I came to talk about tonight. I came to talk about a different segment of our industry, which I think is really going to grow and become the huge space here. And I think it's an area that's very well suited for the San Diego and Tijuana community to be the leaders in. So I really want to talk about, fortunately, that's not a bridge that's in San Diego or Tijuana, but it is a bridge in the United States, and it looks terrible. And it's one of 63,000 bridges that are listed by the Department of Transportation as being structurally deficient. There's bridges all over the place that need repair. Of those 63,000, 20,000 of them are listed as fracture critical. I don't know exactly what that means, but I don't want to be one of the 250 million cars a day that drives over those bridges. We know that they need to be inspected. We know we need to fix them. How do we know what order to fix them in? We have to go out and look at all these bridges. How do you inspect them? Well, this looks like a fairly expensive, complicated, difficult to work device. You need, a flagman up the road blocking the road. This thing's going to block the road. You've got two guys here. How do you do it in something that has trusses and things up above? You can send this guy out there to inspect them. Maybe not so efficient. Or you can send this guy out with the jetpacks. Is it important to inspect the bridges? Well, we know it is, right? We've all seen the pictures, bridge collapses, and these are the bridges that had problems. They looked at them afterward and said this was fracture critical and we didn't address it in time. But how do you know which ones to inspect, to repair first? You really have to inspect them as you go and find the right ones more quickly. But it's not just bridges. It's infrastructure that's all over the country. In the U.S., there are 2 million miles of pipes carrying oil, natural gas, and other chemicals. There's 140,000 miles of railroad tracks. There's 2.7 million miles of high-voltage power lines, of which San Diego Gas and Electric owns 26,000 of them, which are surrounded by 450,000 trees. So how do you inspect all these things? Right now, they use helicopters to do a lot of things. Helicopters are expensive and certainly dangerous. This reminds me of a scene from a Clint Eastwood movie that didn't end up well. You can also go walk around and see them, but I don't know how long these English gentlemen will take to inspect that whole track. A colleague of mine in the audience here has a brother who is in charge of helicopter pipeline inspections for one of the large oil companies in Canada. And he said that the budget for operating the helicopter to inspect the pipelines is $36,000 a day. So even for the oil companies, that's big money. But of course, if you're not inspecting, how long is this thing going to be spewing oil into the Alaskan wilderness? Is there a way to do it more efficiently? This is where we come in. Let's get some UAVs to do the inspections for us. What if I could take a drone and fly it under a bridge with cameras and other sensors, have it go take pictures of all the welds, all the joints, and be able to tell us, where the problems are quickly and efficiently. Fly around the power lines and poles, send a robot anywhere that you need to do inspection. So this is where 3D robotics comes into play. We build unmanned vehicles. We build vehicles for consumer, but we also build vehicles for inspection. This is our autopilot, the Pixhawk, which is used in all of our vehicles and is used in a huge number of other unmanned vehicles around the world. We make copters, fixed-wing planes as well. So you've all seen the consumer craft. You've seen people flying their drones around and taking videos, and they're lots of fun, and they're very cool. And that's the start of the curve of the industry, but it's really the enterprise space that's going to drive innovation. Agriculture is a great area to tackle. It's the low-hanging fruit. There's so many things that you can do if you can map farms. You can detect disease. You can determine which things you want to pick and harvest first. You can find where pest infestations are. Lots of different types of sensing you can do with just basic cameras or doing special sensing of different types of vegetation indices. This is a video of some of the work that we're doing in 3D robotics. We're using a fixed-wing aircraft, and we're flying it over the Kunde family vineyard in the Sonoma Valley. It runs along a prescribed path, driven by the autopilot with a fixed camera on it, takes a number of still pictures, and then runs through some software to join all those pictures together and create a map of the entire farm. Then in real time, this is Ryan Kunde, the owner. He can go look through and determine which parts of the farm need special, to be addressed in a special fashion. And in this case, he's determining where he wants to harvest his grapes first. He could only figure that out by walking around earlier, and it would be much less efficient. Another thing that we can do is 3D mapping. We've got an application that we've just come out with that'll be released shortly, which is a one-button 3D mapping operation where you don't have to control the drone at all. You simply take out your mobile device and you push the map button. I don't know how many of you have been to the Fry's facility up in San Jose, but it's got a Mayan theme to it. It's a really cool-looking building. So we did a one-button mapping operation with this, took a bunch of pictures, ran them through some stitching software, and created this 3D model of the building. So lots of great applications there. Oh, sorry. Going to go back and just introduce this. Another application we have is called Follow Me. And I won't talk over this, but essentially it's a way to have the robot follow you where you go. Right now it's based on a mobile device with an antenna on it. Soon it'll be just a bracelet that you wear. Ultimately it'll be either just a little tab in your pocket or it'll just sense you visually. Android phone with an antenna on it. So you think of all the great applications for that. Sure, it looks like fun, have it follow you while you're biking, but you know, in the industry, you could use it to protect first responders, protect military personnel. There's lots of great things you could do with an application like that. Nature Conservancy. Our autopilots are being used all over the world for various applications. They're tracking rhino poachers in Africa. They're tracking herds of elephants in Asia. Tracking the deforestation of forests in South America, tremendous number of applications there. And then if you just sit there and start to think about it, what else could I do with a UAV with a camera and sensors on it? It's just endless, the possibilities. We can think of all sorts of them in our little office. I bet everyone out here is thinking, wow, I've got a great idea for what you could do with that. But between the environment, first responders, construction, lots of different types of photography. It's an amazing number of things you can do. And the things that we can do here in San Diego are really just the right impetus for making this happen. There's a lot of great robotic things already happening here in San Diego. All the large drone manufacturers are here, Northrop, GA, BAE. Qualcomm is doing some amazing things here with their Snapdragon processors. They've got several different labs that are all working on different applications for things that they can do with incredible smarts of a full computer in a tiny little package. And they're using those to develop some of their own internal technologies. And then they've also, they're incubating a company here that you'll learn a whole bunch more about from Eugene called the Brain Corporation, which again is doing amazing things with the Qualcomm Snapdragon processors and using great software techniques to make robots a lot smarter. Some other of the companies that we've been speaking with, 5D Robotics, Aerial Mob, you saw those guys outside, Vision Robotics, my old company that's doing great things in agriculture. And I apologize to the others of you in the room that have great new robotic startup companies. I'd love to talk with you about them afterward. The future of robotics in San Diego is also here. Al's got a great team of young people coming up in the robotics space, the Coordinated Robotics Lab that you're going to learn about from Tom going forward. And I have to give a shout out to my 3 interns from UCSD who are working for us this summer, Sandra, Andrew, and Fabian, who are doing an amazing job. So thank you, Dean Pisano. So where do we take it from here? Well, this is really the birth of a huge new industry. This isn't going to be a flash in the pan. These things aren't going away. You're going to see robots becoming more and more capable, lots of things happening in the future. And I really want us to be leading that space here in the San Diego and Tijuana area. Possibilities for innovation and growth are just huge. And I've heard people throw around the term Drone City USA. I don't know. We'll see if it sticks. But it's a pretty exciting prospect. One last video to show you, I think, if I have a little time left, and then that'll be it. And this is just an example of some cool sports photography that you just couldn't do any other way. I'd like to say that's me. Thank you all. Now I'd like to introduce the CEO of the Brain Corporation, Eugene Izakevich. How did I do? Thanks, Eugene.
How many autonomous robots have you seen today? Just raise your hand if you saw at least one robot today. Roomba counts as a robot. 2 robots. Oh, 3 autonomous robots, different robots. Oh, some hands. 5. Wow. I saw 5 robots today also. And actually, it's we want more autonomous robots, right? This is the promise of the last century that actually never been fulfilled. But there are so many dull, dangerous, and dirty jobs like the 3D that autonomous robots should be doing for us. But why aren't they here? Why are there only 3 people counting me, who saw 5 autonomous robots today? And the reason for that is that it's very difficult to make a robot autonomous, to behave on its own. You need a lot of programming. Every room, every kitchen, every house is different. It requires a lot of software engineers. So, and this is the reason that because they have to be programmed, they're expensive and they're maladaptive. In fact, Scott Hassan, who is the early architect of Google, famously said that robotics is not a hardware problem, it's a software problem. You need to program your robots. And it takes tens of millions of dollars and huge teams of engineers working for many, many years to make a simple robot that's going somewhere, grabbing an object and bringing it back. So we at Brain Corporation asked the question, what if robots had a brain? Would they behave like animals? Can you train them instead of programming? Would this somehow make it easier for us to come up with new types of robots which will take care of us and do our household chores? So robots having a brain.
This is your brain. And this is a machine that acts like it has one. Meet Roomba, the vacuum cleaner, the world's best-selling robot.
It looks autonomous. It looks like you turn it on and it goes out there. It vacuums your floor. It has this feeling as if it's an animal.
But of course, the Roomba doesn't really have a brain. Instead, it relies on some fancy mathematical formulas to find its way around a room. And those formulas don't always work.
They're reactive, they're not proactive. They cannot anticipate what's going to happen. They cannot learn from their experience.
Mathematician Eugene Izakevich believes robots could learn from their experience. And he thinks he can make that happen by using a model of the brain he created in his computer.
So this is the simulation 20 times slower than real time. Just imagine this picture 20 times faster and 100,000 times more dots. This would be the size of the human brain.
His models of brain activity are so accurate, they can fool the experts.
If you show them to biologists and you hide the caption, biologists wouldn't tell the difference between the real and the fake.
But Izakevich knew he couldn't fully simulate the way the brain works until his model took account of the complex branching shapes of the individual nerve cells that make up the brain, called neurons. That's where neuroscientist Hermann Kunst enters the story, with a scientific breakthrough.
To have a good model, we need to have the information about the shape of the cell.
Kunst figured out a way to recreate, with a computer, the shapes of every one of the billions of neurons that make up our brains. Kunst's model is based on a single mathematical rule, one that makes his artificial cyberneurons look just like their real counterparts.
All the dendrites at all different phases follow this rule.
Hermann's work is a simple algorithm, something relatively simple to implement, and yet creates the connectivity that we see in the brain.
It's based on the idea that the tree-like structures of neurons, called dendrites, connect in a way that uses as little energy and material as possible.
Every system in nature wants to minimize certain costs. Using this model, we can actually understand what nature did.
To Kunz's amazement, his model follows the same principle sketched out a century ago by the pioneering neuroscientist Ramon y Cajal.
Cajal is the founding father of modern neuroscience. He understood so many things. He was really looking at the shape of individual brain cells. The thing that's really new about my approach is that I actually can use these rules to generate shapes in the computer that look like real neurons. To understand the brain, really, we need to look far beyond the single cell. We need to look at the network and many cells and the whole connectivity of the brain.
When I first saw his images, I think it's impossible. It's something wrong here. It's a joke. Then I looked closely and it makes perfect sense. If I take his model and put it into my simulation, this is a perfect match.
Izakevich invited Kunz to team up on an ambitious project to develop artificial nervous systems for robots. They are working with Qualcomm, a leading technology company. Qualcomm hopes that Kunz's models of human biology might help them design smarter microchips.
What I did here is I just took the original slide, which you see in the background. I erased all the dendrites.
When we first saw Herman's work, what was really intriguing about it was the ways in which the neurons connected.
Paul Bender is Qualcomm's Senior Vice President for Research.
To create models, you need both the people who make the measurements, the biologists, but you need the mathematicians who can, distill those into models that, make sense.
We can actually look at the real dendrites in development and see how does biology actually implement these rules. And that's very interesting.
They make models that look like the biology so that they have a chance of performing like the biology.
If you have a cat brain simulated in a small chip, they will understand what's going on in the environment. They'll have an understanding of the context.
I started out thinking it was going to be completely, almost impossible. And yet we're marching along and we're actually making progress.
So ideas that once seemed far-fetched, like robots that think ahead or cars that drive themselves, may soon be a reality. All because of research into the secrets of the human brain.
The brain is sort of one of the last big mysteries to be solved. There's so much to learn about it.
So here you see that the goal of Brain Corporation was to bring advances in neuroscience and machine learning, computer science, to build brains for robots. But why Qualcomm? Here I'm asked Matt Grob, my colleague in CTO of Qualcomm, to explain why on earth Qualcomm is interested in this topic and why Qualcomm funded Brain Corporation almost 5 years ago.
Mobile is a very challenging design environment. We're under constraints for power, performance, size, and it turns out that a brain is incredibly high performance at these same features. Very power efficient, incredible density of performance when you consider all it's doing. So all the processes we've done to date are sort of derivatives of von Neumann type architecture, Harvard architecture, where you've got a processing unit, you grab memory, you grab data, you compute, you store the result. We've gotten much better at it, multiple cores, caches, and so forth, but they're all basically extensions of that idea. A brain is nothing like that. So we're looking now to biology to inspire us for a new generation of processors. So where is this going? This is a picture of a chip that's in a cell phone, which is our core business, Qualcomm. And you can see it's got CPUs, GPUs, graphics, DSPs for signals, codecs for video, modems and communications. Clearly, that's our thing. And we're envisioning now that there'll be this new type of processor, the neural processor unit, that will have a place on these kind of products. And then, for example, if your phone goes off when it's not supposed to, you, instead of going into menus and configurations, you say, bad phone bad, phone good. And then it will learn, taking in all this context, and it might be able to do some amazing things that it couldn't do before, or you may be able to teach it to do things, like you train your dog without having to have a lot of expertise. So there's some very fascinating potential with that. Very parallel tools, design tools are very important here, human-like functions. So that's our goal.
So Qualcomm funded us 5 years ago, gave us a place here at Qualcomm campus, and we were in stealth mode for 5 years, up until 2 weeks ago, developing mathematical models of mammalian visual system and mammalian motor control system. So the first thing, if you have a robot, robots have to see. This is the first thing they require. So how will we build a visual system for robot? Easy. We just copy and steal from biology. So here's a illustration of what artificial visual system would do. On the left-hand side, you will see where the system is looking. This is the gaze, this is saccades, where the system is looking. On the right-hand side, this is a diagram of the model. It has retina, which is in the back of your eye, thalamus. It has areas V1, which is in the back of your head. It has dorsal and ventral pathways all the way to cerebellum. So we take as much biology as possible into consideration in building this model. So here actually we ask the model to just free viewing, no instructions whatsoever, just look at the movies or still pictures and saccade where you find the most interesting and like in humans and animals, it will saccade to something which is moving or something, for example, which looks interesting for the model. And not surprisingly, animals and humans find exactly the same features interesting. This is sanity check to see where the model is looking. It looks in something which looks different. Something which is salient, something has different color, or maybe differential motion, or maybe different orientation, or different contrast. So this is the sort of, this is the simulated brain, simulated visual system at its rest, just looking with no goal and no instructions. You can give it instructions. You can say, okay, I want you to look at something and track it. And this is what, in this example, the system will track an object. This is what the system sees. This is the only square it sees. You see the outside, it doesn't see it. So it tracks this object or other objects in the presence of some of the distractors or occlusions in a different background. So this is the most detailed model of the visual system, biologically detailed, spiking model of the visual system. Take into account different cortical layers, different layers of the cortex, and it performs very similar to the best computer vision algorithms for tracking, even though it wasn't built for tracking. It wasn't built for saliency detection. It's just built to copy biology. So here are a few examples that it's tracking in the presence of people distracting it. Here just it tracks this object, even though there's a similar object, slightly different size, but the same shape and color, trying to interfere. Of course, sometimes it's like an animal. It will saccade and take a look. Here actually we prove that it's not pure color-based, although color is very important, just as black and white. And this is tracking based on shape in the presence of occlusions and other distractors. What you see here, like here, just continue tracking this and looking around, is something that an animal would do, but something that computer vision system probably wouldn't do. Here we have occlusion and distractor, which has the same color as the target. So what if you can take this visual system and you put it inside a robot? What will happen? So the robots will need vision, but they also need motor control system. And for motor control system, I found a better person to present the whole concept than me. Unfortunately, this person couldn't come here tonight, so he sent this video instead.
Even a child can tell that a spider is alive and a rock is not. But what if a lifeless object became a life form? Can life begin inside something that's dead? Eugene and his team think they have found a way to do this. Instead of giving robots step-by-step instructions with a program to make them move, they want their robots to figure out how to move and learn on their own, just like living conscious beings. They are building their robots' electronic brains modeled on biological ones. Neurons are the brain cells that help conscious biological beings like these dogs learn. We may think biscuits are the key to a dog's learning, but it's actually the neurons in his brain. When a dog learns how to fetch, the neurons in his brain fire spikes of electricity that create pathways. As he practices more and more, his neurons fire faster and faster, and electricity flows more efficiently down the new pathway.
Our approach to robotics is quite different from the standard approach. We don't program robots. We endow them with artificial nervous system and their own experiences. For example, robot starts by moving their hands and moving their necks and just exploring their own body. And after that, users, people can teach robots the same way as they teach dogs and cats different tricks to reward and punishment.
Eugene and his team use different body shapes to see how many kinds of movements a robot can learn. This robot is trying to learn how to stand up. Its artificial brain is telling its body how to move. By endowing Eugene's artificial brains with a body and letting them explore the world, these robots acquire experience. They develop behaviors.
So now we know that robots with artificial nervous system or with brains could indeed learn like animals. They don't need to be programmed. They can learn from their own experiences. So 2 weeks ago, we announced a beta developer program for brain operating system. This is this operating system like Android OS or Windows operating system, which basically allows robots to learn instead of being programmed. We provide a piece of hardware. This is a stripped version of it, 2 eyes, based on Qualcomm Snapdragon technology. This has multi-core processor, multi-core CPU, DSP, GPU, FPGA. This is actually, with all the connectors, this is Swiss Army knife of robotics. In fact, it can be used as a Ubuntu Linux computer on its own. You can develop and program inside this board. But what's important, what distinguishes this board from any other Linux computer, that it has vision. You can use, this is the only mobile board that can run sophisticated visual processing, which you can put inside your robot. And in addition, with motor control, the whole brain operating system software, you can put it inside your robot, and you can train your robot to do what you want instead of programming it. You don't need to write a single line of code to endow your robot with some behaviors. So please visit us at brainos.com. Thank you. And it's my great pleasure to introduce Professor Tom Bewley, who supplied us with enormous number of amazing students from UCSD to develop this kind of robots, which will benefit from having brains.
Very much. Technical details as we do the switch here. Sorry about this. Here you go. Thank you. Sorry. Okay, thank you. Oops. Thunderbolt, it's not a Qualcomm technology. Okay, perfect. So, thank you. I'm at the Coordinated Robotics Lab at UCSD, and when I think about our lab, the first thing that I think about is the people that really makes it happen. Have had the wonderful opportunity of working with an amazing group of graduate students named here, and many, many undergraduates and master students working with them. These are really the engine behind my lab, and I think are going to be a commanding force for robotics in the San Diego area in the future. I'll be presenting what a lot of these talented folks have done today. The lab really started back in 2004, not by me, but by a group of students who attended one of my classes. About midnight, the night before final exam, when I started writing the final exam, I had this idea of, well, why don't we try to make a self-writing mobile inverted pendulum that has some sort of spring mechanism inside that it can hop like a pogo stick, and it can use the wheels as reaction wheels when it's in the air. And so, hey, wouldn't the students have a fun time working for 3 hours on an exam question like that? Of course, making a vehicle like that enables the death-defying pit-of-fire leap, as shown there. And so I thought, being a typical academic, that I would give this exam. The students would spend 3 hours on it, and then it would go in some folder, and we had solved the problem, and that would be it. But lo and behold, 3 of the very talented students came up to me after the exam. They said, hey, we want to stay here and do our master's degree and build that thing. And that started the robotics lab in the mechanical engineering department at UCSD. Not me, but those really talented students saying, let's see if we can take this idea to the next level. And the question is really, how can we do, oops. I don't know where that sound is coming from, but there we go. So the question was, how can we do mechanically simple solutions for complex problems? And the answers that we develop at UCSD is leveraging dynamic modeling and feedback control. And so what is control? You've been doing it since you were 1 year old when you learned to stand. Human body will naturally fall over. If you don't have the inner ear in your eyes, you will fall over. When you're a little bit older, you might have gone in the kitchen and done something like that. That's feedback. If I close my eyes, there's no way that I can do this. And if you make the problem a little harder, you can make the pendulum shorter. And get the cue stick going here. And you can try to balance that. You're going to have to move faster because the center... Thank you. Do that in front of 600 people and not drop it. Very good. I could control one, I could control the other. That's about the feedback that I can keep up with my meager brain. So I challenged the student to take a single hand. Here we had a little cart that moved back and forth. And don't put one on it, but put 2 of them of different lengths. One that you control slower because square root of g over L, the time constant of it, is slower. The other one is faster because it's shorter. And let's make the problem a little bit harder. Let's not start from near the vertical condition, but let's start with them hanging down. And this goes beyond what the human brain can do. That's what a computer can do when doing feedback. Right? That's the magic of feedback control. That's what we specialize in the lab. Going back to that original final exam question of can we make a self-riding Segway-like vehicle that can stand and ultimately hop, we made some reduced versions of them that didn't yet hop, but were just rolling around. And boy, were they a lot of fun. We started talking. We started talking to the toy industry and said that would really work as a toy. Wouldn't that be a fun thing to try? And we started doing a little bit of ball play. And that guy didn't very reliably pick up the ball, and it kind of lobbed it like that, a little dainty thing that didn't go very far. We contacted 2 different toy companies and said, hey, you want to make this as a toy? And we didn't quite hit it off then. And so we went back to the lab, and that little thing that we now call a mobile inverted pendulum sat in the drawer of shame for a couple of years. A couple of people looked at it. Nobody could figure out, hey, what's the effective way to pick up a ball without adding more complexity to this thing, without adding more motors or anything. Effective way to pick up and energetic way to throw it, until another young talented master's student came along at UCSD and said, I've got an idea. 3D printers are coming out. I'm really good at 3D design. I'm using CAD. Let's shape the bottom of the vehicle kind of like a boat hole. When the vehicle's rolling along, it will pinch, say, a ping pong ball between the bottom of the body and the wheel, and as the wheel turns, just the motion of the wheel will pick up the ball and store it in some little a container in the top of the vehicle, and then from time to time when you want to drive this thing by remote control into the kitchen and beam your mom with a ping pong ball while she's making dinner for you, couldn't you do that? This is the solution that that he came up with. And so he actually built it, rolled over the ball, pick it up, and then it can lean back and throw in an energetic lacrosse-like fashion instead of that little lob that the first design did. Went back to the toy industry, hit it off with the company, figured out how to make that vehicle smaller, more robust, using the newer electronics. Arduinos were available instead of the original PICs that we're using for those things. Miniaturized it, figured out how to make it robust, and then went forward with the toy industry. I'll come back to what finally came out of that. But in the meantime, when developing those model-based controls, we need to, like they do in General Motors or Ford when they're developing a new engine, we needed to have a dynamometer that really characterized the relationship between the gas pedal and how much torque we get out of the engine. In this case, characterize the signal that's coming out of the computer through the motor drivers and into the motor, through the gearbox to how much torque we were actually getting on our vehicles. There wasn't a solution available for that, and so we developed our own small motor dynamometers that now everybody, when they have a project in the lab, can pick this up and use this. You can too. It's available now open source. So you give back to the community when you do this stuff. It's a really fun give and take. It's really fun watching everybody work together in the lab. We also worked closely with our collaborators in the toy industry to figure out how to make maximum use of pick-and-place type machines in order to minimize the amount of human effort required to manufacture these in very, very large volume. We've developed several other designs, other more serious designs. Don't have time to go through all of these today. If you enjoy this stuff, you can take a look at the videos, longer video on the website that has several of these designs. We did pursue the hopping designs and actually built them very energetically and efficient. If you take a look at how the Apollo astronauts move on the moon, certainly hopping in low-G environments is good. But in Earth-based environments, hopping is not so efficient. We took a little different slant rather than looking at walking sort of humanoid locomotion. We were looking at things that were minimalist designs that make maximum use of wheel and treads. One of the designs that we were thinking about back when we were looking at this is how can we make a Segway-like vehicle inverse slinky upstairs by having the wheels climb the post and then use it as a reaction wheel, tip over, and keep on going up. So we had a few preliminary designs. We're working on a new build of that right now. We have some treaded designs, like the one shown here, that can articulate its arms and separately articulate the treads around the arms. And this is the first tank that can get up and stand on its tippy toes, which is pretty exciting. Have some other maneuvers like a successive perching maneuver to get upstairs. Have some vehicles for going underground or in HVAC systems in order to explore them. This thing has a linear actuator on the bottom and another one on the top. So like a rock climber, it can pinch on the bottom, extend itself by actuating the vertical tendons in order to get taller, and then it can pinch on the top and pull in on the bottom and pull the saddle tendons to get shorter, and so it can go up like that. We've got a self-propelled sphere that has all sorts of reaction wheels inside that you can gimbal the axis of, and so it's called a control moment gyro, the same way you point a telescope in space. And this thing has so much torque that it can roll its way upstairs. So imagine a mission like this, where you seal one of these things, you release it near shore, it rolls along up until the surf zone, it submerges, rolls through the surf zone, over sand, over vegetation, through barbed wire, and upstairs. The only small robot that can survive a mission like that is a SphereBot, because there's nothing to get caught or junked up on the outside. And the special way that we do it with these energetic flywheels inside called CMGs gives us an extra amount of torque that fundamentally there's a performance limitation that other SphereBots, which are essentially RC cars inside of beach balls, can't even touch. And so might mention that we have patents on several of these designs through the UCSD Technology Transfer Office. They've really been the ones who help us connect with industry. One of the hardest things about connecting at Qualcomm is that it wants you to log in. One of the hardest things about keeping up in the field of robotics is how quickly the technology changes. So when we started 10 years ago, most people were working with PICs, and Arduinos then came out later when we developed this low-cost robot I'll show you in a minute. There's the inexpensive line of the ARM family. This thing costs 80 cents when you buy a million of them, which is pretty darn amazing considering it's 32-bit and faster than we need to do all of this sort of balancing maneuvers. We've also had a close relationship with National Instruments over the years. What a Linux computer when I was in graduate school was about the size of a sack of potatoes. Now a similar Linux computer is about the size of a credit card and costs $50. Full-blown Linux computer about the same speed as what I used in graduate school is about this size and makes for an excellent educational platform. We've developed a class teaching students about that. We've made some versions of our ball picking up and throwing vehicles together with Brain Corporation. And what we're excited about the future of where things are going is something that's not the size of a credit card, but something that's not much bigger than a postage stamp. And this was announced by Charles Bergen here at ComNexus in the event in December. These are the specs that he provided for it at that talk. And the short of it is it runs at between 0.2 and 1.3 watts. And it has a speed of about 10 times the fastest computer in the world in 1985. Imagine what we could do with something like that if we used it to do more than play Angry Birds. This is going to be what's going to drive technology next. So as Al mentioned, a big part of robotics today is finding context. Where are you going to go next? Back in the 1980s, the problem of simultaneous localization and mapping, or trying to draw a map based on driving and looking what you see, was developed in a computer game called Rogue. And then that evolved over the years at Google and some Kickstarter projects, but perhaps most notably what's going on right here at Qualcomm. There's a whole bunch of work in the fields of simultaneous localization and mapping, and the associated 3D version called Structure from Motion. Our little explorations at UCSD involve taking some of our small Segway-like vehicles, moving them through smoke-obscured environment, and trying to find things. And we've paired the thermal images that we can get from small IR cameras that are now in the neighborhood of $1,000 a piece, but the price is dropping quickly, with the corresponding RGB signals. Put that through the appropriate reconstruction algorithms, and you can build 3D virtual realities that you can just then paint with the thermal information in order to find an object that you're looking for that would be otherwise obscured in junk in your 3D fields. And so now, finally, in the direction of algorithms, the algorithms behind what the computers, what the robots do, is perhaps the hardest part and one of the most important parts, and something that we focus on in the lab a lot. And this is collaboration between the theory side of the lab that's looking at various flows and the people who are developing and dispatching vehicles to autonomously solve problems. One of the problems that we're quite interested in is the problem of looking at developing plumes. We all know that the smoke from Iceland, the ash from Iceland, the oil from the Deepwater Horizon, the radiation from Fukushima, there's a lot of uncertainty as where those plumes are going, and that was important. And so we believe that developing small mobile vehicles that are moving around within these smoke plumes can take in situ measurements. We can get a lot better estimates using weather forecasting class algorithms than we can just using satellite observation alone. And so one of the things that we're working on is figuring out how to dispatch vehicles in order to make an estimate match the truth. Refer you to that website for more information on what's going on there. This is a brand new result that we're showing the first time today of some other algorithms that we're doing where If you fly an airplane over a hurricane, back in the 1950s, my father flew airplanes over hurricanes and was dropping out sensor packs in parachutes that could in situ go through the hurricane and measure the moisture and the temperature and the pressure and get a fix on the location and send it back via radio, and that's how they helped do their weather forecasting. They still do that today. 50 years later. We should be able to do better. We shouldn't need to make multiple flights over a hurricane, drop down these sensors, lose all of them. And so the idea is that why don't we build some balloons that can last for weeks at a time in a hurricane and disperse them uniformly over the hurricane, or quasi-uniformly, and then get the in-situ measurements, have those things survive for days at a time in the hurricane environment. So this is 8 days into the development of an actual hurricane. This is actual data, 3D time-varying data of a hurricane profile. We had a simulated airplane flyover, release 4 balloons, and if you take a look at the time average profile of a hurricane, it's pretty cool. The winds come in at the bottom, out at the top, viewed from the top, they go round and round. And so the idea is there are some manifolds, some regions, if you take a look at the time average profile, where the average radial velocity is 0. So if you get on that manifold, you'll just go around and around the hurricane. So now the question is, if you put a bunch of vehicles, let's say we have 2 vehicles there, but they're too close together azimuthally, what you can do is you can take the one in front, take it, this is a balloon. I'm not going to fight 100-mile-an-hour winds. All I'm going to do is move up and down in this heavily stratified flow environment. But if I take the one in front, I can move it down, after which it will come in and go around the core faster. I can take the one in back, move it up, after which it will go out, move around the core slower. Once they separate the desired amount azimuthally, you can bring them back to their equilibrium altitudes, after which they come back to their equilibrium radii, but now appropriately separated azimuthally. This works in full-blown 3D time unsteady environments. We're really excited about that. To sum up, yes, we're also doing work, of course, in education. We've developed, together with a talented group of students and our collaborators here in San Diego at ATA Engineering, we've developed an embedded control and robotics class where each student gets a $160 bag of parts and builds up their own little Segway-like vehicle. And it's very rewarding for all of the students. And here are some of the features that you can read on your own. Of course, one of the most important features in a vehicle like this is these little things right here. Everybody involved in robotics, of course, knows what this is. Every good robot needs one, right? A blinking light for no apparent reason. And so, of course, all of our vehicles have the Bliffnars. Finally, I wanted to now introduce you to what we're coming to market with. This little creature is effectively known as MIP. Nice thing, it doesn't have any extra switches. You just change the modes by turning the wheel, and you can let him go. Kids love these things. Of course, being in San Diego, you can't do a robot without strapping a GoPro to it. So there's a version with a GoPro. And of course, now that technology has gotten so inexpensive, we can put low energy Bluetooth in these things. And so if he will cooperate and connect, there we go, we can drive him around. And so, whoa. And so I was going to try to do the video feed in real time from that little GoPro, but I'll leave that to you guys. Those are available now. Check them out at Huawei.com/MIP. So the process, if we could switch back to the slides, please. The process of bringing that to market was an engagement between our lab at UCSD and Huawei, and also the tech transfer office at UCSD, which really facilitated the collaboration and the connection. And it's the first of many, so stay tuned. I have been sworn to secrecy on some of our internal lab projects, so I can't tell you all the details. Suffice it to say that when you go into Target or you go into Toys R Us, there's very much a blue side and a pink side of the store, and a lot of the cool tech is on the blue side of the store. We're going to be changing that. So there's a lot of good things that could be done. It's going to be rewarding for me because we're going to get this in the hands of millions of people on Christmas morning and get them excited about tech and the robotics as it's developed in San Diego. That's going to be a big satisfaction for all of us. To sum up, I guess these are points that Al already brought up, that you can call it the 3 C's. I call it sense, decide, and act. It's EE, it's CS, it's mechanical engineering. The theme is really to bring all of this stuff together. NSF would call it co-robots, pick your favorite word, but really doing these collaboratively, not with a single vehicle, but leveraging the low-cost manufacturing so we can figure out how to make many vehicles to do a squad or a swarm. So if you lose a few vehicles when you're deploying them in a fire, doesn't matter, they only cost $100 a piece. Get in there with a bunch of vehicles and figure out what's going on. And the other point is that it's not easy. Design is the most visible part of what we do to the public. It's the most patentable. Technology is constantly evolving, and you need to evolve with it. And finally, the algorithms is the most fundamental part, but it's also the most abstract and hard to describe. But San Diego has some amazing things going on in all of those areas. So we're working to commercialization to keep robotics in the public eye, create broad impact, and at UCSD we're providing experiential education for the robotics force in San Diego that's going to help us carry this forward. San Diego and UCSD have, as the other speakers mentioned, unique core strengths in all of these areas, appropriate that we're here at Qualcomm today. Just a final plug, we're working towards making the presence of robotics even stronger at UCSD with some sort of Masters of Advanced Studies for professionals students, so you can find out more information there. Thank you. One more thing I forgot to mention. We had a little raffle so one of you doesn't actually have to go to the store because we have one to give away today. And so I will, in this very random method, pull one out of this hat. If anybody recognizes their card, that will help me because I'm not good at pronouncing names. We have Corin Littleburn, Vice President of Sales at Thorncrest. Corin, where are you? Here? Back there? Here's your MIP. Come on up and get it. So again, thank you, and I'd like to reintroduce Rory here.
Okay.
So.
Thank you, Tom. Okay, I'd like to bring the panel up here, please. Is our winner coming down to get the... Where's the winner? Here comes the winner somewhere. All right. Okay. Let's start with Dean Pisano. As you saw in his bio, I think he was around when they invented MEMS, which is quite some time ago.
Thanks.
Your background in MEMS technology over many decades not only makes you the best person on the panel to address my next question, but just maybe the best person in the country. Just as the 4G network, Moore's Law with silicon, and breakthroughs in technology, display technology, and mobile apps has brought huge changes to the mobile handset sector. What sort of compelling consumer product categories in robotics do you see MEMS playing a part in?
All right, so first off, I have to say that I think I should quote Yogi Berra, who was the manager of the Yankees, who said, "I never make predictions, especially about the future." But aside from that, so the question is, what are the apps that are looking at the sensors? So I would offer the following. Based on what we've seen tonight, we know that the future is robots that are going to be trained. The sensors are going to be the sensors that you want the robot to use to perform the function you train it for. So just as for the PC, there was no one killer app that drove it into existence. It was when the software total became big enough, it became important to have a PC on your desk. What I think is going to happen is that the market is going to select the app by what people most train the robot for. So I think you're going to see an entertainment sector. I think you're going to see a safety and inspection sector. And I think you're going to see basically a security sector going to really rise quickly.
I'd like to see one for the pet sector. I have 2 puppies that could use a robotic trainer.
Well, so you didn't mention actuators, and the second step would be to clean up after them. But
right.
First, we'll let you know where it lies. The chips may fall where they may.
Tim McConnell with 3D Robotics. Your background has been to essentially take research and development from the science sector and then design and build robotic systems that the industry and consumer can use in compelling ways. Your company, 3D Robotics, has gained significant attention in the media, investors, and drone customers. You are developing a very diverse product line that can impact a number of important sectors. Over the next 5 years, what do you see as the greatest opportunities for 3D robotics to impact the consumer in the way that the smartphone is done?
So I love the question, Rory. And I think to think about the next 5 years, I really want to think about the past 5 years and where we've come since then. 3D robotics has been around for just about 5 years. And when we first started, we were a complete do-it-yourself company, you know, totally serving the RC enthusiasts, the kids that took apart their radios when they were young and that liked to solder things together and put things together. And it was a great marketplace for us, and it's really helped to birth the whole industry of UAVs, where people could put them together and they could make cool things happen. That's got saturated after a while, and then over the past couple of years, we've seen it really grow into the consumer space, where people don't want to have to solder these things together or put them together. They just want them to work. They just want to put their GoPro on and get great shots. The space going forward, as I talked about, is going to be in the enterprise space. It's going to be real growth. But there will be lots of things done in the consumer space as well. And if you think about all the cool sensors that are being developed that Al's talking about, and the incredible expansion and capability of tiny processors that Tom was mentioning, and the things that you can get on a little chip, and then all the software that's going on in the Brain Corporation and the things that will be developed there, you're going to be seeing development of small, lightweight drones, UAVs that people can use, that they don't have to learn to fly. They'll do the things themselves, and people can just tell them, this is what I want you to do. And the beauty of it will be that you can just tell it, go follow my 2 dogs. You know, go find out where I need to clean up after the dogs, and not have to spend any time thinking about how do I control this thing. It's just going to work on its own. So that's going to be the exciting thing, is that people won't think about the fact that it's a UAV. People will just think about it as this cool object that goes out and does cool stuff. I learned something from one of the guys that works for Brain Corp today. They have a new measurement I'd never heard of before, which is flops per ounce. You know, how much smarts can you get in a tiny package? And that's just going to increase so much, so you can get these things that people will use, and they'll just do great chores for them.
Terrific. Well, this really leads into a great question for Eugene. You know, when I learned about Eugene's background and what they're doing at the Brain Corporation, first thing I thought about was the Terminator movie. You know, Eugene's making a Terminator, you know, learning, mimicking mammalian brains. So, Eugene, I don't know if that inspired you. Maybe Arnold inspired you. I'm not sure about that. But if you just heard what Tim has said about that, the consumer being able to command something. You know, your description of what has to occur is very complex. And in order for these products to understand speech recognition, is that possible?
This is your question?
Yes. Can you devise a robot to actually recognize one's speech?
My iPhone recognizes my speech with my Russian accent.
So there.
Yeah, so here we go. But it's speech recognition actually is a solved problem. Understanding it is very difficult. What is even more difficult is to understand your visual input. just to sense, to perceive what you see and how you should act when you see something. And just follow up on Tim's question and answer that no, we don't want to build. The science fiction writers of the last century predicted it will be big humanoid robots, multitasking robots doing all chores in your house. And what we think is going to happen during a very short period of time, not even our lifespan, but just next 3 to 5 years, is that it's a proliferation of small, specialized, inexpensive single task robots, which do only one task, but do it well. We already have example. iRobot made a great job of bringing Roomba the vacuum cleaner to consumers. And there are a lot of imitators now for the same product, but it's only cleaning the floor. But imagine you have the single task robots doing other chores in your house. Of course, we have a saying that it's a robot when it doesn't work. The moment it works, it's an appliance. So think of a huge number of appliances, of small robots. And I think San Diego will be the center for creation of such an army, such a crew of robotics because of UCSD, Jacob School of Engineering, the great neuroscience and cognitive science department, because all those robots need brains, and we hire a lot of people from UCSD and from San Diego area. Because of Qualcomm and a Snapdragon processor right now gives the best performance per watt, per gram, or per dollar. Nobody else can beat that. It's the best processor on this planet. And even though it was designed to go into smartphones and tablets, but it's a great processor for robotics because of the low power consumption, high performance. So you have hardware, we develop software, and you have manufacturing facilities here in Tijuana where you can spend your morning in your lab, your company. For the lunch, you go to Tijuana to see, which is Chris Anderson doing, just to see the prototype in our manufacturing facility, and you go back to your family in the evening. You couldn't do this with China, with the language barrier, the 14-hour time zone difference. So this will be the center. San Diego missed on social networks and .com revolution. It didn't miss on telecommunications. It didn't miss on biotech. This will be the center for consumer robotics.
One of the things I learned about Dr. Bewley and his background, he's a diver and scuba diver. And I thought about, some of the things that have occurred in robotics in water. And a few years ago when they had the British Petroleum well blowout, by the way, at 5,000 feet underwater, and it was a 36,000 foot drill site. They had a catastrophic event. It was catastrophic for BP's balance sheet as well. And what occurred down there, the repairs were all done with robotics. You can't get a diver down 5,000 feet in a submarine. It was all done with robotics. Cap the wellhead. So as you look at what occurred there, which was an amazing accomplishment, and you look at harsh environments for robotics, some of the things that come to mind have to do with energy and natural gas and wind. What do you see are some of the biggest contributions in the area of energy for robotics?
I guess I'd like to come back to that word that Eugene used, was appliances. So actually, mechatronics and computer intelligence have been creeping into every part of human existence over the last 30 years, slowly. And some of these things we don't even anymore recognize as robotic systems, like our dishwasher, when we're and various appliances around the home. I would say similarly in the coal, natural gas, oil, nuclear industries, more and more things are getting automated and running more and more efficient all the time. So we see these things happening in an incremental way, and those will continue to happen. I think one of the more dynamic things that we're going to see, as Tim was pointing out, was the gathering of information about unknown unknowns, and using autonomous unmanned systems to do it. There was an event here a couple of months ago about a data summit about how cell phone technology merges with the processing of large amounts of data in order to get an understanding, in order to do things better that we couldn't do before. That's universal, from getting cell phones to post to Twitter feeds during World Cup games more reliably, to applications that you're asking about in the energy sector. So I would say the unknown unknowns that we're looking back to are events like this thing at 4,000 feet down, or a nuclear spill that happens somewhere. I had one slide up there about trying to track plumes that can come from these efforts to get energy, which are getting more and more difficult. And so being prepared with autonomous systems to figure out where the oil is going. Is it going into the sand below? Is it going to wash up on the shores and kill all the tourism in Florida? Is it going to kill all the fish? Is it going to get picked up by the Gulf Stream and go out? We didn't know. It was embarrassing how badly we used autonomous systems to measure where that plume was going, but it was quite impressive, and I think all of us were following it with bated breath to see the capping operation that was going on down there. So as far as using big data, I would say one of the areas that we're working on in the lab is wave energy conversion. So trying to forecast waves, individual waves, before they get to these machines that can extract energy from ocean waves. We can make them 3 or 4 times more efficient if we can just predict a little bit in advance how much energy should we take out of the next wave in order to get the maximum bang out of every wave that's coming along. And we might have a new viable source of energy that can compete with wind if we do that. Managing large solar wind farms, again, how much power do I take out of each windmill in order to get the maximum out? These are big data problems that couple with robotics, and I think that's one of the exciting things that public's going to get appreciation of in the next 5-10 years that will really impact how we can efficiently produce energy.
Well, as you can see, I think San Diego is uniquely positioned to take a leadership role in this area. I remember when the Cold War ended in the late 80s, the Berlin Wall came down, and just a huge amount of tech transfer occurred out of the DoD. We have quietly built out the center of the universe for unmanned and autonomous systems with the drones here, and I think a lot of that's going to also start to develop into commercial usage, so I think there's going to be a spillover to that. But I want to thank all of you here tonight for coming. I'm looking forward as leader of the organization to help others build out this sector. Thank you all for coming tonight. Enjoy the rest of the evening. Good presentation. Oh, nice. Thank you.